Alright, today we're going to talk about lesson 25. I can write a fraction and a decimal as a percent of a whole quantity and write a percent of a whole quantity as a fraction or a decimal. Now, that's a lot of words there, but basically what we're going to be able to do here is take a percent and write it as a fraction and a decimal, and vice versa. Example 1. Sam says that 50% of the vehicles are cars. Give three reasons or models that prove or disprove Sam's statement. Models can include tape diagrams, 10 by 10 grids, double number lines, etc. Alright, so we need to prove Sam wrong. Well, it should be pretty easy. I like to prove people wrong, so it says, let's figure out how to do this. 50%. Well, what is our total number of cars? We have 3 cars and 2 trucks. So I could make a similar tape diagram, or maybe just a model of this to disprove this. So here's my first one that I'm going to do. Okay, so I'm just going to make a model. That's supposed to be a nice, neat rectangle. And we have cars and trucks. Okay, so I'm just going to label this car, 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 truck, and truck. So this fraction that we have here is we have 3/5 of our total. So the cars take up 3/5. And we know that we need to figure out that Sam says 50% of the vehicles are cars. Well, if I have 5 things here and I multiply those by 20, that's going to get me to 100%. So I could say that this is like 20%, 40%, 60%, 80%, and 100%. So if I look here, I can see that cars are going to take up 60% of that space. It's definitely over half, so that's more than 50%. Now let's look at another way to prove this. I'm just going to write my fraction, 3/5. I'm going to multiply it to get to I'm going to multiply it by a number to get to 100, because remember, percents are always over 100, written as fraction form. So I can multiply 5 times something to get to 100. Let's see, 20. Whatever I do to the bottom, I have to just do to the top. So 3 times 20 is 60. So I know that 60 over 100 is equal to 60%. Okay, that's more, so Sam's wrong. And let's make a 10 by 10 grid. We are going to say the cars are, and this is broken up into 5 things, so I could say there's 5. Nope, not that one. Okay, so here you can say that this is C, that this is broken up into 5 different grids. 1, 2, 3, 4, 5. And I know that the cars take up 3 of these bars. So now we are left, and clearly you can see that there's only 2 left, and that's only 60%. So Sam's wrong. So let me look back and give 3 reasons why our models to disprove Sam's statement. Well, I've given 3. Let me finish out this question. It says, how is the fraction of the cars related to the percent? Well, if I take the fraction 3/5 cars to total, and I multiply it like I did in number 2 by 20 over 20, I'm creating an equivalent fraction of 60 to 100, which is 60%. So I could say the fraction is related to the percent because it shows out of 100. And remember, a percent is per 100. It says, use a model to prove that the fraction and percent are equivalent. Well, I have two things here. I have a fraction and percent that I need to compare. Well, what I want to use here is I could use a double number line. Now, when I first looked at how to do this, it was like, what? And so I was a little confused. But I think this is a much easier way to show you how to do this. Let's say that this is the percent. If I label this, remember all tape diagrams start with 0. So the top row is the percent, and the bottom row is the fraction. Okay, we started with 0. Let's start with our first one. Our fraction, we're going out of 5 here. So we can say our first fraction is 1/5, and that would be 20%. Second fraction, 2/5, and that would be 40%. Notice how we're counting by 20s on the top row, going up each time on the bottom. 3/5 is 60%, we have proved that. 4/5 is 80% because 60 plus 20 is 80. And our last one, of course, 5 out of 5 is 1 whole, which is equal to 100%. All right, and let's do the last one. What fractions or decimals can be represented by, or can represent 60%? Well, remember that 60% is just saying 60 over 100, which can be reduced to get to 6/10, which can reduce again if we divide both of these in half, which would give me 3/5. Now let's look at 60% as a decimal. Remember, this is 60 hundredths, so 60 hundredths. Remember, we can drop the 0 here, which is also equal to 6/10.